but it does not help really, because I'm writing on the table, so it's not table, blackboard, sorry. Yeah, it's still, I still speak English sometimes or again. Okay, so good afternoon everybody. We changed the room because I think it's better if I have more blackboard. And we learned new stuff yesterday. It's the vectorial product and also determinant matrices and other things. So we will practice that one. It will be not so easy. I have the notes, but it is in Hungarian, but don't worry, I will translate. Of course, your test and everything will be in English. Just now I don't have so much time because I have to spend 2 days in Budapest every week, so it's catastrophic. It was not, so my life is not as easy as I planned, and it doesn't matter. So, let's start. The most important feature or new information is this vectorial product. So you can multiply a vector by a scalar, do like it, it's okay. You can multiply two vectors, it's called inner product scalaric, then the result is a scalar. And the third one, that's very important, when you multiply two vectors and the result is a vector. So for the length of the new vector, it's called outer product. For the length of the vector, we have this term. So the length of the two vectors multiplied with the sinus of the angle of the two vectors. From this, some thing is this sinus function has some consequences that we used very soon, and the direction, that's important. There is a definition that's very bad, so it's better if you use your right hand. The A cross B is a right-handed system. So this is the direction of the E, this is the B, and this will be the new vector. And these vectors, so this new vector is perpendicular to the B and perpendicular to the E. Actually, with this, so in physics, in space cosmophysics, or anywhere, you can determine the direction, the normal of a plane in the three-dimensional space. You have one vector that you know it is somewhere on the space, there is another. You do a cross product, and then you get a vector, which is the direction of the normal vector of the plane. The problem is that with this example, you haven't learned the equation of the plane in 3D space, so sorry, you will understand a bit later. So if you do this vector product with a null vector, then the result is a null vector. Some other important features that we will use immediately. Okay. So if not this one here. If you multiply a vector with itself, then you got a zero vector. Why? Because the angle is zero, its sinus is angle, so the angle is zero. If you have this A cross B and the result is a null vector, then the vectors are parallel. And additional things, this three, the scalar product, or just a normal multiplication, or a multiplication of vector and scalar is commutative. You can multiply A with B and B, you got the same result. Here not, that's important. It's called anticommutativity, and at least we should be happy because we have this. It's easy to understand why. Look this plot. It's much not the best, but much better than my hand. So my plots, which are A cross B gives this direction. But if you say B and A, then the direction is the opposite. So this is anticommutativity. The sign changes, the direction changes. That's an very good feature. The next one, if you multiply a vector with a scalar and then do the cross product, then it's the same like do the vectorial product with A and B and then multiply with a scalar. It's a general feature. It's homogeneous. At the class, at the lecture, I defined you what is linearity, and that was one feature. We will use this one. And the product is dissociative. You can multiply vectorially with this A plus B, and you can divide this operation. You will see very soon why is this important. Okay. The vectorial product with components, this is just a line here. But this is very important. So this how you will get the coordinates. It means it's easy to miss and make mistake. I do very often, perhaps not at the blackboard, but there is a chance. Yes? Okay. Triple product. Yeah. We have three vectors. Do the vectorial. Can I help you? Can I help you? Okay. So we do the vectorial multiplication, and then the cross product, and then we do the scalar product, and that's the mixed product. We will use it. It's very useful. We use it. Okay. And my experience is that we will not reach the matrices today because I had the same class last afternoon with the Hungarian team. So I jump to the notes, and we have this one. Does anyone use the Moodle, or everyone use the Teams? You use the Moodle. Okay. Then it's worth to upload the things there. Okay. Sorry, it is Hungarian, but you will understand it. Don't worry. Yeah. Okay, that's here. Okay. There are three vectors, this E and B and the C, and we have to calculate the following vectors. We had done the first, the fourth, the fifth, the sixth, and also the eighth. So we will do the rest of. And it will takes time. So the first is to calculate the A keres B. I will do it, and then later you will also do it. So A keres B, A cross B, keres, sorry, it's Hungarian, A plus B. I'm a bit tired, so my weeks are quite busy, and sometimes when I'm tired, I use. Can you see? No? You and you? I hope so. Okay, that's. And the life is not easy. At all. I don't know why we use these jobs. Here, we need this term. So first component is the second component of the first vector, the third component of the second vector. Then the opposite, the third component and the second component. Okay, next component, the third component. The first component minus the first component and the third component of the second. Okay, then first times third, second minus can you see it from there? Not really. So that's 12 minus plus 18, then 2 minus 4 minus 2, and then 2 plus 3, that's 5.
Sorry, isn't it 16?
Sorry?
Isn't it 16, not 18?
Which one? This one?
Yeah.
Okay, so this is 3 times 4. It's and then
Plus 4.
plus 4.
16.
It is 16.
16.
Instead of 18.
Oh yes. It's Friday, sorry. I apologize. Thank you. You are listening. Great. Any other mistake? I hope no. Not. Great. So, as you see, the life is not easy because you have to apply this form always. It's easy to miss. Okay? Yeah. Okay. Now, we'll do something. The next one is this term. A plus 3b across A minus b. As a good physicist, I would use brute force and waste many time. It's much better to use your mind a little bit. But that's the most difficult thing. Most of the people cannot use its brain. It's not a problem, so there are many animals that has no brain at all, and that has a nerve network system, and they exist for hundreds of millions of years, but here we should use our brain. And for me, my perhaps you can see better.
Sorry, excuse me, it's minus vector b.
There is, oh sorry, yes. I need stronger coffee. Friday morning, thank you. Okay, now it's good. Okay. We have the task, and now we remember. For these, because we will use these terms. The vectorial product is dissociative. It means that I can multiply this term with this term, and then this term and this term. It's very similar with numbers. But these are not numbers. That will be minus. When we will deal with the matrices, that's here at the vectors and matrices. If you do the operation from the right side, is same or anticommutative if you do from the left side. But there are operations, for example, matrices which are different. Doesn't matter. Okay, so this is a dissociative operation. So here you can do the operation separately again. Okay, here, so we use this dissociative feature. Otherwise, we cannot do it. It's not a real life, not a secondary school. We can do, which is allowed. You know, remember, not thinking like this, you think like this. Okay? Here, we have a new information. Here we multiplied the A vector, I mean calculate the cross product of A vector with itself, it's 0. Here also the B is multiplied with itself, it's also 0. So we have free B cross A minus A cross B. However, we know that the operation is anticommutative, so I can change the A and B. It will be then minus 3A cross B minus A cross B. So the final result is minus 4A cross B, minus 4 times A cross B. For this, it means we have this vector, the A cross B, and we just write was also someone yesterday who asked the same question. Here, this is the feature that you are asking, and sorry, I forgot to refer for this. You understand? You understand. She understand, but the other understand. That was an important question because without permission, without the rules, I can't do this. I cannot do this. Okay? Okay. Great. Yes. Could you write this down?
Yeah.
Okay, great. Because I know this. When you do the test, it's quite simple. Perhaps you know it. But always, when you start, read everything. And then before you start to do the selected exercise, read the full exercise. You can spare time because here the steps are built on each other. Okay, so the next question is the triple products of A, B, and C. That is A cross B, scalar product C. That is good because we have E cross B. And the C is 4, 1, 3. So how you calculate the scalar product? Multiply each component to each other, and then add. I mean, make the sum. So it's okay. So it's I'm right. We spared time because we have calculated this here. Do you understand? You're looking strangely? No? Okay. Yes?
Can you please explain that why 5 multiplied by 3 is positive?
Could you please repeat why 5?
Multiplied by 3 is positive.
Is it so here 5 multiplied 3? Because it was here, it's positive. It's the scalar product.
Okay.
So we take the components of the vectors, multiply, and then sum everything.
Okay. I understand that. Thank
Okay. Okay. Great. Great. Okay, what we have? So this was this task. Oh, and there are results here. Okay. Yeah, we were good. Very good. Next one. We have the following vectors, and yes, we have to do the task 2 and 3 and 7. Okay. You was not here last Friday. We had an important discussion. Okay, sorry, I talked to him, and would you please do the operation, the first one, A cross B, without me. I show you the formula here. Okay, just do it. Okay, until I talk. So you have learned this, and we discussed that you can accept. You can ask the register office to accept your process. Yes, it doesn't matter, but we will learn the same things like then it doesn't matter. You send the form description, and I will check the topics. I will check what you done, and if your study is over this one, then I will accept it. And then you don't need to come. But if you have done, great. And you can do it. When you was here, we discovered that no one told them it's possible. Yeah, but they didn't know. So do it separately. With Algebra, she just told that next week is still fine.
What about the subjects that I don't know?
I will check. If it's less than 30%, then I will accept. If not, okay, this is university. You have the right to come to the lectures. Everyone from the street can come to the lectures because this is a university's general rule. This is a media age. You, the only right is for the students, is for the colloquium, for the exams. So you can come with one people who can learn the new stuff, and you can also teach this stuff if you want. It's your decision. But if half or semesters or all this is known, I will get it from the semester.
So actually, because I already applied for the should I edit that transfer application?
Actually, she with the blue hair. What's her name? Sorry. Nani. So she knows how to discuss each other after. But don't send emails or their life. Very Hungary. So Germany, Hungary, other countries, they answer emails, and they answer also. Of course, always. Yes. No, first you do the process. And then for my email, I send new material, and I will check. Yes, you can do it. Yes, and okay. You can do it. You can this way. You can this way. Okay. So, are you ready?
Yeah.
I also sent you some collection of rules and laws and everything. I suggest to read it. It could be different than in your university or previous university or the things in your country. Actually, the Hungarians haven't read this in Hungary, and they had strange questions to me, so I suggested them to read, and then I looked for the rules in English. Okay, so it was B, but what was the A and the B?
312.
Thank you. It's very similar, but different than the other. Okay, so.
The first one is 1 times 4.
What I had done?
A2 times B3.
Where?
And the first one.
The first one.
Yes, let's.
Yeah.
1 into 4.
What was it? Was sorry. Oh, it's
A2 B3.
1. B3 is it's 4.
1 times 4.
Thanks. The other is fine.
And
Thanks. Okay. So A 1 3 3. Okay, and then 1 times what is it? Okay, so it's 4 4 0. It's minus
negative
2 minus it's yes, and 6 plus 7. Okay, and I can say not the nicest, sorry. There's the result, but this is nicer. So this 0, 2 minus 1, and the minus 7 is before it. Yeah. Okay. The next one is
So why is it minus 7?
not minus 7. What I have done, here the components, it's 14, this 7.
Okay.
So I can take this color before the vector. This is the result. This is a nicer written of the result.
Yes, understood.
Okay, okay, the next one. That's critical. Can you try to do it yourself? I mean, do not do this calculation. No, I do it. And the next one, you will do it alone. So first, here, you do not do this calculation. You can do it, but it's better not. This is the previous. No, that's it. dissociative. And because it's Friday, I do the same, this thing. No, it's okay. So, this is so what I have done, I divide into two parts this, like this. I did the operation and also use this feature that allows me to move the scalar from the vector to the beginning. I multiplied A by E, A, B by D. So it means that I have this term and also have this term, and this is B cross A, but we know that it could be written A cross B, so it means the result will be minus 3, so A cross B. But no, this is the task to calculate that one. So minus 3 times minus 7, and that is 0 to minus 1. So it means this will be 21, so 0, so 2 minus 1. So that's the real end of the task, the exercise. So what I had done, before I did any calculation with numbers, I calculated. I used the terms, the features of the vector product. Okay, it's okay?
Yeah.
So now we have to remember A cross B is this term, I mean this vector. Because the next task is to calculate the triple product A, B, C. That is A cross B, scalaric product C. However, A cross B is here. And we need C, that is 1, 2, 3. This is 3. Scalaric multiplication is nothing more than 0 plus 1 plus 2 times 2 minus 1 times 3, that's 2, no, it's 4 minus 3, it's 1, so the result will be -7. Do you remember how to do the scalar product? No? But you asked addition, not addition. That's a task you always task. Sorry? Which one? Sorry, what is that one? What is the? Oh yes, okay, great. Yeah, that is written. Okay, I will give Yes, because if you add this together, then that's one. Because this is if you calculate. No, it's not. It's plus 2. It's not minus 2. The second component. It's plus 2. Yeah, and you do yes, and then yes. Okay. I will give you homework once I can breathe and live, and we have enough task to learn. Okay. Then the next task is the following. We have these expression, and we have to calculate everything and give this term as some multiply. So A cross B multiplied something, a scalar or a vector or anything. A plus 4B cross A minus 2B. Is it good? Good. So what can we do? This vector product is dissociative. So you can divide this operation into 2. Just draw this again. Do cross product with A minus actually the 2 could be put here because it is allowed. So this is allowed. Okay. You write A cross A plus 4B cross A minus 2A A cross B minus 8B cross B. And what does it mean? This is 0, same vector. This is 0, same vector. And this means, this means 4B cross E, that nothing more than minus 4A cross B, because of the anticommutative feature. So minus 4 minus 2 is minus 6A cross B. That's the result. So you can deal this vectorial product like, well, not like, it's like multiplying polynomials with the ordinary numbers. Okay, could you please do me the B, the next, yourself? notes are there, but unfortunately it's Hungarian, so that's why I read it and do it practice. All slides are there, and also the notes there, and there are 2 English notes, books, actually 2 books here for people that are student find them on the internet. Okay, I'm looking for a victim. Okay, please. You are my victim. Please fix the and explain how your brain is working. I mean, what do you do?
This bracket.
Yes.
And it becomes 3a cos.
You open that one. Why can you do it? Why can you do it? You can do it, but why? This is the dissociative feature of the vectorial product. So you can do it because it is allowed.
Okay. Yeah.
It's okay. Everything is okay. Just
the same thing would
yes.
be.
Cross. Okay. No, it's oh okay.
I open brackets once more. Sorry, minus. Oh.
No problem. It's happened all the time.
So, here we can see that here we have the same vector
Yes.
and it becomes null
Yes.
vector, so we can cross it out. And here is the same situation.
Yes.
Cross it out, and we are left with this. So this operation is
Commutative.
commutative. Yeah.
Don't learn my pronunciation actually, so it's not not perfect. Yes.
Yeah. So if we switch A and B,
Yes.
we have to change the sign.
Yes.
And it's going to be we are also have to move 3.
Yes.
And the result is going to be 6. 8 or 3.
Yes. Just underline the B and the A and B. Okay, that's it. And underline twice because you are ready. Thank you very much. Perfect. Thank you. Thank you. Thank you for your assistance. Okay. Some of you look so desperately. Okay. The next, I remember for the next next task from yesterday. So from this slide, left, you do the first term, calculate the first term. Right, you calculate the second term. And then we work together at the end and calculate the result. is you?
And left side.
Left side. Okay, great. So why can you do it? That's good. Just why can you do it?
Because it's the property, I think.
Yes, yes. No, that's okay. That's enough. Okay, so the task was, we were almost, let's check, okay, yeah. The task was to get A equals B. So it's almost good. Just the final step is minus 3 times A equals B. That's an additional step. Okay. Cross. Yes. Use the sponge. My secondary school, my later chemistry teacher always told me not to use donkey skin. I mean, doesn't matter. You cannot do anything. No. A cross B.
Okay, yeah.
But use the sponge. Okay, better. Okay, thank you. And just underline once, because this is a partial result. No, not above light, underline. Underline. Use this. No. Okay. This is tradition. So what you had done, everything was good. It's okay. No problem. So these are vectors. That's okay. And when you ready, then you show it. Usually underline twice, but this is just half of the result.
Yeah.
Okay. Thank you. That's good.
I cannot put the bar above the vector, so I have to underline it, not like above the vector.
You can do it also, but it's better if you don't do it. You can do it, whatever you want.
Yeah.
Just somehow you have to show it's not that it's not a scalar. Okay, so victims. So who calculated the other part? You did it? Yes. Okay, can you do that to us? It's easy because I remember the results from yesterday.
it is plus 3.
It's that's okay. Just here. No. Down.
Plus A plus.
That's wait. Okay, I didn't expect you to do such a thing. Yeah, that's okay. You are right. Everything is right. And here is, and the last step is 3 A plus B. Yes, and that's the joke. Not joke final. Thank you very much for your assistance. So one part is minus A plus B, the other minus 3 times A plus B, and the other is plus A plus B. So the result will be a null vector. Just it would have been too long to do yourself one part. So it's, I don't know. So the result is the null vector. Okay. We are good. We have few minutes, and still we can do other tasks. Question for you. So you have other mathematics course and also practice, I guess. Do you do something similar like we do? What? Yes? So it's okay, great. Well. The next is calculate the area of parallelogram, which vectors are this u and v vectors. So remember here, so A cross B is equal, to the area of the parallelogram determined A and B. You remember this from the lecture. If not, it's not a problem. So it is not expected to remember everything. That's why I use this slides. So what we have? We have more and more piece of jobs. So we have A vector, B vector. It forms parallelogram. This is the angle between them. And calculate as so, and this is the, and this is the length of this vector. So this will be A so we have to calculate here the U cross V. That is. Minus 9. Oh, it's not bad. So this is the U cross V, and we need the length of this vector. That's the area, the surface of the parallelogram. So we need such a Hungary. Everyone's handwriting is better than nicer than mine. So we have length. Sorry. This will be the area of the parallelogram. Sometimes makes things easier. And here you are. I'm good. I mean, this is a good result. We are good together because I stopped yesterday with the Hungarian group, and usually I speak 30% slower in English than Hungarian. So we are good. Have a nice weekend. See you next week.
Thank you.
Thank you very much.